Okay, good morning or good afternoon and welcome to the last video recording for chapter 1 and we will start with the buffers. Okay, so let's begin. Okay. Now, so what is the importance of your buffers class in the body? Okay, ano bang importance ng buffers in the body? So sabi niya dito, the control of pH within narrow ranges is critically important in many chemical applications and vitally important in many biological systems. Okay? Every living being must maintain a controlled pH level within the systems in order for different chemical reactions to occur. Okay? Kasi yung mga different chemical reactions na nangyayari in between or inside your cells keeps us alive. Okay? Especially to humans. And these chemical reactions only occur if certain types of ranges of pH levels are maintained. So, dapat, yung katawan natin, meron tayong mga controllers of pH. Okay? So, ano yung nagko-control sa pH range ng ating body systems? Number 1 is your buffers. Okay? Very important ang control of pH level, especially in your biological systems. We have here an example. Okay, your human blood. So the human blood must be maintained between pH of 7.35 to 7.45, which is slightly alkaline, for the efficient transport of your oxygen coming from your lungs to the cells. Okay? Dapat maintained ang range ng pH blood or ng blood pH within 7.35 to 7.45 in order for your oxygen to be transported galing sa lungs mo papunta sa different cells found inside the body. Okay? Now, you call this as narrow pH range. Itong 7.35 to 7.45. Okay? And that is maintained by the buffer systems found in your blood. So, ito yung example natin. So, this is the gas exchange happening between your body, between your lungs and the cells of the body. Okay? So, I hope you are going to take this up in anatomy and physiology. Okay. The buffers are solutions which, ito yung function nila, they resist the pH changes when diluted or small amounts of acid or bases are added to the system. Okay? If nagkaroon ng slight change in the pH level of the different body fluids, then ang magpe-prevent niyan is yung inyong buffers. Okay? So, if magkaroon ng addition ng small amount ng acid, so your buffer will prevent the decrease in the pH level. The extreme decrease in pH level. And it also prevents extreme increase in pH level when a small amount of base is added to the system of the body. Okay? So, the pH limits are so critical that the body uses two buffer systems to maintain it. So, ito sila dalawang general buffer systems that are found inside the body to maintain the critical pH limits of your body fluids. The first buffer system that can be found inside your body is the sodium dihydrogen phosphate and disodium hydrogen phosphate. So, dalawa yan sila partner ha. Kaya nga sila buffer system because it is composed of two types of chemicals. Uha? So, magkadikit. Pair yan silang dalawa. Sodium dihydrogen phosphate, this one, and disodium hydrogen phosphate, which maintains an equilibrium as shown in the equation. So, tingnan natin. Ito ang kanilang structure. Sodium dihydrogen phosphate. So, do you still remember the naming of your structures? I hope you remember So, bakit naging sodium dihydrogen phosphate ang pangalan niya? If you can see in the structure, there is only one sodium atom found in the structure. So, sodium. However, there are two dihydrogen atoms found. This one, 1 and 2. Uha. And then, phosphate, nakikita mo sa gitna. So, sodium dihydrogen phosphate. Next, you have your disodium hydrogen phosphate. So, dalawang sodium ang makikita mo kaya may di sa unahan niya. Di meaning 2. Disodium, 1 hydrogen, and 1 phosphate. Okay? So, that is the structure, chemical structure of the first buffer system. Now, nabanggit niya kanina, no, ano yung equilibrium? So, sabi niya, itong first buffer system daw maintains an equilibrium as shown in this equation. So, when you say chemical equilibrium class, this involves the reactant side and the products side. Oha, left side are the reactants and right side are the products. In this case, isa lang naman, no? So, singular sila. But anyway, a chemical equilibrium will happen when your reactants and products are present in the concentration which have no further tendency to change in no time. No observable change in the properties of the system. So, meaning, pantay ang concentration ng reactants sa products and walang nangyayari na backflow of reaction. So, hindi nagbabago yung inyong reaction. Stable lang yung reaction ninyo with the same concentration on both sides. That is what you call chemical equilibrium. And that is the target of your buffer systems. They must maintain maintain the chemical equilibrium of the systems of the body by preventing changes or extreme changes in the pH level of the fluids. The other buffer, aside from our first buffer system, may isa pa, no? And you call that as hydrogen carbonate carbonic acid buffer. Ito naman yung pangalawang buffer system na makikita sa katawan ng tao, and it is actually involved in the maintaining respiration. Sa respiration ito siya. Okay? So, yan. Sige, balik tayo dun sa naunahan, nakalimutan kong banggitin. By the way, saan ginagamit itong first buffer system natin? Sodium dihydrogen phosphate partnered with disodium hydrogen phosphate. Ginagamit siya for maintaining the pH level of the internal fluids inside our cells as well as maintaining the pH level of your urine. Okay? So, itong buffer system na ito, responsible siya sa pag-maintain ng pH level ng fluids inside your cells and also maintaining the pH level of the urine. Kuha? So, i-take note yan. Ano naman ang gamit nitong second buffer system found inside the body? Ang gamit niya, this is based on the abundance of carbon dioxide generated in the process of respiration. Kasi diba, kapag nagkakaroon tayo ng respiration, there are plenty of carbon dioxide that is produced. Okay? So, the dissolution or yung separation or dissociation ng ating carbon dioxide in the water produces carbonic acid. Okay? So, kapag masyadong, if there are plenty of carbon dioxide free floating inside your body, okay, when it comes in contact with water, it produces carbonic acid, which is a weak acid which is unstable and dissociates readily to carbon dioxide and water as shown in the reaction. So, our body maintains the level of carbon dioxide inside the body to prevent our system from becoming acidic. Kasi nga if masyadong maraming carbon dioxide, okay, nagproproduce siya ng weak acid, carbonic acid. So, nagiging acidic yung environment inside our body. So, kailangan meron kang hydrogen carbonate, carbonic acid buffer system that will prevent this from happening. Paano niya ginagawa yun? For example, when your carbon dioxide comes in contact with water, it produces carbonic acid, H2CO3. Now, yung H2CO3 mo, pwede namang mag-come in contact siya with water to produce what? Hydronium ions. And your HCO3 ion. So, anong mangyayari? Mas magiging acidic, no, yung ating system. Now, take a look at this. If the blood is too acidic, okay, meaning masyadong maraming presence ng carbon dioxide sa blood, then the hydronium ions react with your bicarbonate ion, which is the HCO3 negative, forcing the equilibrium backward to form more carbon dioxide and water. The excess carbon dioxide is now expelled by exhaling it. So in this process, para ma-lessen yung acidity ng body, you will exhale the excess carbon dioxide. Pero bago mo magawa yun, kailangan muna maging backward ang they call this, ang direction ng ating reaction. Okay? Ayan o. So, if your blood is too acidic, ano ang gagawin ng reaction? Ang direction niya is from this side papunta sa kabila. Kuha. So, kapag acidic ang ating blood, yung hydronium ion mo, mag-react siya with your bicarbonate, which is your HCO3 negative, to form your carbon dioxide and water. At yung na-form yan na carbon dioxide, which is hindi ginagamit, that will be expelled through exhalation. Kuha. Or exhaling. So, that is the process of lowering the acidity of the blood. How about if ang blood natin is too basic? So, ang mangyayari dyan, imbis na i-expel mo yung carbon dioxide through exhaling, ang gagawin mo, you will consume the carbon dioxide. So, you will dissolve the carbon dioxide forming hydronium ion and bicarbonate ions, which results to neutralizing the excess base and readjusting the pH. So, since basic masyado ang blood, gagawa ka ng hydronium ions. Ito, para tataas yung acidity ng blood mo and manuneutralize niya. Okay, yung basicity. Kuha? So, if too basic ang blood, the reaction or the direction of the reaction is from left to right. Okay, meaning you will consume the carbon dioxide to form hydronium ions, which will increase the acidity of the blood, thereby neutralizing your the basicity of the blood. Kuha? So, if too acidic ang inyong blood, ano ang direction ng reaction? From right to left. Meaning, hydronium will react with bicarbonate, forming carbon dioxide that will be expelled through exhaling. If the blood is too basic naman, ang direction ng reaction is from left to right. Meaning, you will produce more hydronium ions to increase the acidity of the blood. Okay? So, I hope that is clear. It is the shifting of the equilibrium point in response to an imposed stress that allows the maintenance of an essentially constant chemical environment. Kaya nga nakita nyo dito sa reaction, ang ating mga arrow are double-sided, 'di ba? So, dalawa ang direction ng mga arrow natin, left and right. Meaning, this whole reaction is reversible from left to right and right to left. So, nag-change lang ang direction ng equilibrium ng reaction na ito depending on the stress that is imposed on your system. Depende lang if yung stress na sinasabi natin dyan, whether too acidic ang blood or whether nagiging too basic ang blood. Nakuha? So that is what you call the use of chemical equilibrium and the changing of the direction of the equilibrium as an as a result of the imposing of stress to the system. Okay? So this one, sige, tapos na natin yan. Let's continue with this. Composition and mechanism of buffers. Now, we will know the different compositions of our buffers. Ano yung different types ng buffers natin and how they work to control the pH level. Okay? So, there are two types of buffer solutions. Number one is an acid buffer. The second one is a basic buffer. So, unahin natin ng acid. Acid buffer is made up of a weak acid mixed with the salt of its conjugate base. Tandaan, mixture siya ng isang weak acid and yung salt ng kanyang conjugate base. An example of this is an acid buffer combination of a weak acid, which is acetic acid, and its salt, sodium acetate. Bakit sodium acetate? So, 'di ba? Acetic acid natin is a weak acid, meaning ang conjugate base niya is acetate. So, since acetate is present in this salt, then it is, sodium acetate is a salt kasi nga nandyan yung conjugate base ng acetic acid, which is the acetate. Okay? So, combination siya ng sodium hydroxide na base and acetic acid, which is a weak acid. So, sodium acetate. The combination is shown by the reaction. Okay, acetic acid, reversible yung gamit niya dito na arrow ha. So, acetic acid will dissociate into hydrogen ion and acetate ions. So, ito yung para sa acetic acid mo. On the other hand, sodium acetate naman, it will dissociate completely. So, hindi na reversible ang arrow na ginamit mo. Kasi, hindi na siya pwedeng bumalik, no? So, if it dissociates completely, forward arrow lang ang gamit mo. So, meaning, your sodium acetate will completely ionize into sodium ions and acetate ions. Nakuha? So, pinagkaiba nila, ang weak acid mo kasi reversible siya kasi nga hindi siya nag-ionize completely. Now, a solution containing these two substances has the ability to neutralize either an acid or a base is added. So, kapag ang buffer system mo daw meron nitong dalawang reaction na ito, it will prevent or it will neutralize your added acid and base on the solution. Since sodium acetate is a salt, then it completely dissociates in water. If an acid is added, the hydrogen ions will be consumed by the conjugate base in the buffer, according to this equation. So, if nag-add ka daw ng acid, 'di ba ang acid natin meron silang, when they dissociate in water, they will produce hydrogen ions. So, yung hydrogen ions coming from your acid will attract, no? It will be attracted to the acetate ion of your buffer solution. Itong dalawa na to. So, acetate ion plus your hydrogen ion coming from the acid will produce acetic acid. Now, if base naman ang idadagdag mo dito sa buffer solution na ito, so, 'di ba ang base natin, ano ang binibigay niya? Hydroxide ion. So, since negative siya, okay, it will be neutralized by the acid in the buffer. So, saan siya pupunta? Itong negatively charged hydroxide ion natin. It will be attracted to the acetic acid produced by your buffer solution. Nakuha? So, if acid ang nilagay mo, since positive hydrogen ion siya, ang positive will be attracted to negative. So, saan siya pupunta? Dito sa acetate ion. If base naman ang dinagdag mo, since negatively charged ang hydroxide, this will be neutralized by your acetic acid to form water and your another acetate ion. Nakuha? So, ganyan siya. Okay? So, this is the reaction that is happening when your acetic acid, sodium acetate buffer will be facing addition of acid and bases. So, yan ang example natin ng acid na buffer system. There is a limited range over which a buffer is most effective. Okay? The range is often called as the buffer range. Wait lang, parang may kulang. Okay, may kulang nga. May right? Nasaan ang ating buffer? I mean, salt or base buffer. Wait lang, class ha. I will just add the picture. Okay. So sorry for that, class. So na-hide pala yung slide, yung next slide, kaya nawala siya sa presentation. Okay. So let's continue. Okay. So the second type of buffer is a base buffer. This is consisted of a weak base mixed with the salt of its conjugate acid. An example of a base buffer is the weak base ammonium hydroxide. This is a weak base and a salt ammonium chloride. Okay? So, ayan. Okay. Ammonium chloride is coming from a strong acid, hydrochloric acid, and then the ammonium coming from your weak base, which is the ammonia. Kaya siya isang salt. Kuha? So, this is the reaction. Ammonium hydroxide, okay, when it reacts with water, so since isa siyang weak base, ayan, so reversible yung reaction mo. So meaning hindi completely ionized. So mahati siya into ammonium, NH4+, and hydroxide ion. On the other hand, your ammonium chloride, since it is actually a salt, diba? Sabi natin lahat ng salt will be completely ionized when it reacts with water. So, ang kanyang direction of reaction or ang arrow niya is only on the right side. So, it will be completely ionized into ammonium, NH4+, and chloride ion. Okay? Cl negative. So, a buffer solution must contain a relatively large concentration of acid to react with any OH ions that may be added to it. Okay, so sabi niya, dapat ang isang buffer solution daw, meron siyang enough na concentration ng acid in it so that when you add an additional base, manuneutralize niya yung base, diba? Kasi nga, meron siyang acid. On the other hand, it must also contain a similar concentration of base to react with any added hydrogen ion. So, dapat meron din siyang similar concentration ng base para kapag nag-add ka ng small amount of acid, it will neutralize the hydrogen ions brought by your acid. Furthermore, the acid and the base components of the buffer must not consume each other in a neutralization reaction. So, 'di ba? Ang ating buffers, they are either they have components of both a weak acid or a weak base and a salt. Okay? So, dapat hindi nila nako-consume kasi nga if meron silang both acid and base sa buffer solution na yun, dapat hindi nila nako-consume or neutralize ang isa't isa. Okay? Yung acid and base that are found within your buffer solution, they must not fight with each other during the neutralization reaction. So, these requirements are satisfied by an acid and base conjugate pair. So, ito yung dalawang klase ng buffer ninyo, ang components nila. Ang una is a buffer solution containing an acid and a base conjugate. Okay? Pair. So, acid and base conjugate pair does not consume each other, class. Okay? Kasi nga itong acid na ito, kapartner niya yung conjugate base niya. Kuha? Ayan o, a weak acid and its conjugate base, or either a weak base and its conjugate acid. So, kapag ganyan ang partnership mo, they will not consume each other in the neutralization reaction. On the other hand, in general, a buffer system can be represented as salt plus acid or conjugate base plus acid. Okay? So, dyan lang ang pagpilian mo. Either ang kapartner ng acid mo is the salt containing its conjugate base, or pwede rin conjugate base plus your acid. Okay? One example natin dyan is your sodium acetate and acetic acid buffer that can be written as this. So, ito ang example ng isang salt and acid buffer solution. Bakit? Ayan this is a salt kasi meron siyang metal na kasama. Sodium acetate partnered with weak acid, acetic acid. So, yan yung salt and acid buffer solution. Another example is acetate ion paired with acetic acid. Ito naman siya ang example ng isang conjugate base plus acid na buffer solution. Ang conjugate base dito is acetate and ang acid is yung acetic acid. Kuha? So, pili lang dyan sa dalawa. So, the two of these are the two types ng buffer solutions when it comes to composition classification. Okay, there is a limited range over which a buffer is most effective. The range is often called as buffer range. That is the pH range in which a buffer is effective. So, kapag sinabi nating buffer range or pH range, dito lang sa range na ito nagwo-work ng mabuti ang inyong buffer system. Okay? For example, we have here pKa. So again, pag sinabi nating pH range, 'di ba? Certain types of reactions in the body only occur when a certain range of pH is present. Ayan. So pKa for your acetic acid is 4.7. Okay? So, the buffer range for your acetate, acetic acid buffer system is given by pH, from pH 3.74 to 5.74. Okay? Kasi ang formula ng pH range natin is pKa plus negative 1.00. Okay? So, ito yung pH range kung saan nag-work ng mabuti yung ating buffer solution. For example, so, ang pKa ng acetic acid is 4.74. Constant na yan siya. So, sabi dito, i-plus and i-minus mo siya ng 1.00. So, minus mo ng 1 ang 4.74. You will get 3.74. And then, add mo ng 1 ang 4.74, you will get 5.74. So, ang pH range mo for your acetate acetic acid buffer system is from 3.74 to 5.74. So, yan ang pH range niya. So, within this pH range lang, nagwo-work itong buffer system na ito. Kuha? And it works best at 4.74 pH level. Nakuha? However, take note that the buffer functions best at, 4.74. That is when your concentration of acetic acid is equals to the concentration of acetate ions. Nakuha? So, nag-work best yung buffer mo, yung buffer system na acetate, acetic acid, when both concentrations are equal to each other. And that is mangyayari lang yan, yung equal nila na concentration kapag ang pH is 4.74. But it can still work, no? The buffer can still work within the range of 3.74 to 5.74. Okay, aside from that, the concentrations of the weak acid and its conjugate base should be high enough that the buffer can neutralize an appreciable amount of your hydrogen and hydroxide ions without significantly changing its pH. Okay, let's go with the Henderson-Hasselbalch equation. So, itong Henderson-Hasselbalch equation, ginagamit mo ito to find the pH of your buffer solutions. Kung kanina, yung mga ginamit natin na equation is to find the pH and POH or hydrogen concentration, hydroxide concentration of your acids and bases or weak acids and bases, itong Henderson-Hasselbalch equation, ginagamit ito siya for finding the pH of your buffer solutions. Okay? Let us consider the pH of a solution containing a weak acid, HA, and a soluble salt of the weak acid or its conjugate base such as sodium A. Ito daw ang acid mo, weak acid siya. Ito ang magiging products niya when it dissociates with water. H, hydrogen ion, and the negatively charged ion. Okay? So, ayan. Meaning itong buffer solution na ito, weak acid plus the salt. Okay? So, yung weak acid mo, it will dissociate to hydrogen ion and the negatively charged ion. The ionization constant equation is given by Ka is equals to yung concentration ng hydrogen ion times the concentration of the negatively charged ion divided by the concentration of the weak acid. Okay, that is the formula for getting the formula of the ionization or the dissociation or ionization constant of an acid or weak acid. Ito ang formula niya. Dissociation constant or ionization constant, pareho lang yan, ng isang weak acid. This is the formula. Now, rearrange the equation resulting to hydrogen ion is equals to Ka times concentration of your weak acid divided by the concentration of the negatively charged ion. So, ito siya, nag-derive ka lang. Para makuha mo kasi ang hinahanap natin, for example, ang hinahanap natin is the concentration of your hydrogen ions. Paano mahanap yun? So, you will derive, i-times mo itong Ka dito sa baba, sa concentration of your weak acid, and then divide them both with the concentration of the negatively charged. Divided by A negative, divided by A negative, you will get this equation. So, yan na siya. Multiply both sides by negative logarithm, you will get negative log times concentration of hydrogen is equals to negative log Ka plus log times the concentration of negatively charged ion divided by the concentration of your weak acid. So, from that, you will get the Henderson-Hasselbalch equation. Ito na yung Henderson-Hasselbalch equation. pH is equals to pKa plus log times concentration of negatively charged ion divided by concentration of weak acid. Kung saan doon, ang pKa mo, baka mag-wonder ka, ma'am, saan makuha yung pKa namin? Anong value niyan? So, you can get the pKa by this equation. pKa is equals to negative log Ka. Tandaan, yung dissociation or ionization constant ng weak acid natin, always binibigay. Okay? Para hindi kayo mahirapan, di ba? Binibigay na yung value niyan. So, i-times nyo yun sa negative log. That is what you call pKa. Negative log Ka. Okay, so ito ang main equation ng Henderson-Hasselbalch equation. Now, if this equation is used to calculate the pH of a buffer solution. Okay? Para sa acid, pH. So, in general, ganito ang magiging labas niya. When you're finding the pH of a buffer solution, you will need to use the equation pKa or negative log Ka plus log times the concentration of your conjugate base divided by the concentration of your weak acid. Akuha. So, ito yung para sa mga acid natin. How about if ang buffer solution naman, ang pinapahanap sa'yo is POH? Kasi nga, composed siya ng weak base, hindi weak acid. Ito siya is para lang sa weak acid. How about if weak base ang nag-compose naman sa buffer solution mo? So, ganito, POH ang gagamitin mo. Now, POH is equals to pKb plus log times concentration of your conjugate acid over divided by the concentration of your weak base. So, the same with the weak acid, dito pinalitan mo lang ng Kb. Nakuha. Tapos yung pKb natin, you will get that through either pKb is equals to negative log Kb or pwede ring using this equation. If binigay sa iyo is Ka. Okay? If ang value na binigay is Ka, tapos ang hinahanap mo is POH, di ba? Kailangan mo makuha yung Kb. So, if ganun ang case, ito ang gagamitin mo na equation kasi nga wala ka pang value ng Kb, ang may value ka is Ka. So, ang gagawin mo, pKa plus pKb is equals to 14. So, if may value ka ng Ka, substitute mo dito, negative log Ka, tapos, transpose mo sa kabila. You will get the value of pKb. Nakuha? So, marami tayong masyadong equation. So, ilista nyo na yan sa isang papel para if may quiz, so, diretso na mahanap nyo agad yung equation. Okay? So, magkaiba ang equation for finding the pH and finding the POH of buffer solutions. Okay? So, mag-loading muna ang utak. Mag-reflect. Sige, i-absorb muna lahat ng natutunan. Okay? Before we'll continue, sige. Okay na ba? Now, let's continue with the examples. How will you integrate these two Henderson-Hasselbalch equations in the problem solving? Okay, number one example, sabi niya, calculate the pH of a solution containing 0.20 moles per liter of acetic acid and 0.30 moles per liter of sodium acetate. So, this buffer solution is composed of a weak acid and a salt containing the conjugate base of the weak acid. Uha? So, iba ang concentration ng weak acid, iba rin ang concentration ng salt. What would be the pH of a solution if no salt were present? So, dalawa ang hinihingi niya. Hinihingi niya ang pH level ng buffer solution mo. Hinihingi niya rin ang pH level ng buffer solution kapag tinanggal mo yung salt. So, dalawa ang hinihingi ng problem. Now, let's start with the salt. Yung salt muna. Given na rin pala ang Ka mo. Ayan. This is the Ka of the weak acid, acetic acid. Sodium acetate is a salt, which means mag-dissociate siya completely in water, forming sodium ions and acetate ion. So, kapag nag-dissociate completely, ano nga ang mangyayari? Yung concentration ng salt mo, yun na rin ang concentration ng products niya. So, if ang concentration ng salt is 0.30 moles per liter, that is also the concentration for your sodium ions and acetate ions. On the other hand, yung acetic acid mo, di ba, weak acid siya. So, meaning, hindi siya magde-dissociate completely. So, ang magiging product niya, which is the hydrogen ion and the acetate ion, hindi mo alam ang concentration niya. Okay? Nakuha? So, X yung dalawa. X and X. Okay? Wala pa silang concentration. Ang pKa mo, you will get that by substituting your Ka value. So, negative log times 1.8 times 10 to the power of negative 5, you will get 4.74. Okay. Using the equation, so ano ba yung given na buffer? Diba, isa siyang acid. Gumagamit siya ng weak acid. So, meaning, pH ang gagamitin mo. pH is equals to pKa times log concentration of your conjugate base divided by the concentration of your weak acid. So, substitute the value of your pKa, 4.74, plus log, okay? Ano ang concentration ng acetate? Kanina, 0.30 moles per liter or m. So, ilagay mo siya, substitute. Ano naman ang concentration ng acetic acid? Diba binigay na rin? 0.20. So, i-divide mo yung dalawa, i-add mo siya sa 4.74, you will get the pH 4.92. So, ang pH ng buffer solution mo is 4.92. Now, answering the second question, paano kapag tinanggal mo yung salt? Okay? So, meaning, itong 4.92 pH mo, ito ang pH level ng buong buffer solution. Ayan. 4.92 ang pH ng buffer solution composed of acetic acid and the salt Na acetate or sodium acetate. Paano pag tinanggal mo daw itong salt, ano ang magiging pH value ng acetic acid lang? Kasi tinanggal mo nga yung salt niya na component. So, for that, since weak acid ang ating acetic acid, you will use this equation, Ka, dissociation constant of acetic acid. Now, Ka is equals to hydrogen ion concentration times acetate ion concentration divided by the concentration of your acetic acid. So, sabi nga natin, hindi natin alam ang concentration ng hydrogen ion and acetate ion since your acetic acid will not dissociate completely. So, X times X magiging X squared. Okay? Ano ang value ng Ka? Binigay niya na 1.8 times 10 to the power of negative 5. Ano ang value ng ano ang concentration ng acetic acid? 0.20 m. So, i-times mo ang 0.20 m dito sa value ng Ka, and then i-square root mo siya. You will get the answer 1.9 times 10 to the power of negative 3 moles per liter. So, may value ka na ngayon ng hydrogen ions. Now, since you have the value of the hydrogen ion, you can now use the formula of pH. pH is equals to negative log times 1.9 times 10 to the power of negative 3. You will get the pH 2.72. Ako ha? So, meaning, acid nga ang acetic acid kasi ang pH level niya is 2.72. Pero, if titingnan mo yung pH level ng buffer solution, 'di ba? Mas mataas siya, 4.92. Kasi nga may kasama siyang salt. So medyo mas tumaas ang kanyang pH level. Pero kapag nag-iisa lang yung acetic acid, 2.72 siya. Okay? So the presence of common ion acetate clearly suppresses the ionization of acetic acid, resulting to the buffer solution having a less acidic, okay, pH level. Okay, the last example. So, okay, kaya pa ba? Namamalat na si ma'am pero kayanin natin. Sige. A buffer solution is composed of 0.30 moles per liter methanoic acid. Ang methanoic acid natin, class, another name niya is formic acid. Okay? Formic acid. And, so, ayan yun. Weak acid yung methanoic acid natin. So, weak acid plus 0.52 moles per liter of potassium methanoate. Okay, potassium methanoate. Yes, ma'am? Hanggang 12 po, ma'am. Okay, so mabilis na lang ito, ma'am. Last na, ma'am. Okay, 0.52 potassium methanoate. Ayan, so this is a salt. Okay, kasi combination siya ng potassium hydroxide, which is a strong base, and methanoic acid, which is a weak acid. So, given na ang Ka mo, 1.8 times 10 to the power of negative 4. Calculate, number 1, ito yung hinahanap niya, the pH of the buffer solution. So, hanapin mo yung pH ng buong buffer solution. Number 2, pH of the solution after you will add 0.02 millimoles of hydrochloric acid. So, napakaliit lang ng amount niya, no? A very small amount of hydrochloric acid. And the other question is, find the pH of the solution after you added a very small amount naman of your sodium hydroxide. Okay? So, isulat muna natin yung equations nila, or isulat mo muna yung reactions of both of the methanoic acid and potassium methanoate when they dissociate in water. Unahin mo ang salt. So, ang salt natin, since salt siya, it will dissociate completely into water. So, kung ano yung concentration na binigay originally for potassium methanoate, yun rin ang magiging concentration ng kanyang products. So, 0.52 rin for your potassium and 0.52 rin for your methanoate. Okay? But, when it comes to the methanoic acid, since it is a weak acid, it will not dissociate completely. So, meaning hindi mo nga alam kung ano ang concentration ng hydrogen and ng methanoate ions. Okay? Now, for the pKa, negative log, isubstitute mo yung binigay niya na value times 1.8 times 10 to the power of negative 4. Ang pKa mo will be 3.74. Okay? So, since this is a weak acid combined with a salt type of buffer solution, ang hanapin mo pa rin, or ang gagamitin mo pa rin is pH. Okay? So, pH pa rin. So, pH is equals to pKa, itong value niya, 3.74, plus your log times the concentration of your acetate ion divided by the concentration of your methanoic acid. You will get what? So, ano ang value ng acetate ion? 0.52. Ano ang value ng ating methanoic acid? 0.30. Correct? So, i-divide mo yung dalawa, you will get 3.74 plus 0.23. The pH level of your buffer solution as a whole is 3.97. Now, so ito yung answer natin sa letter A. For the letter B, so since mag-a-add ka ng 0.02 millimoles of hydrochloric acid, the salt component will react with it, resulting to the decrease by 0.02 millimoles din. Okay? And the acid component will increase by 0.02 moles. So, 'di ba? Okay. Acid yung inad mo. So, meaning, saan siya magre-react? Since ang acid natin magbibigay ng hydrogen ion, so meaning positively charged ion, so saan siya mag-a-add? Doon sa ating, well, where will it react? To the salt component. Okay? Ayan o. So, the salt component will react with the hydrogen ions coming from your acid. So, meaning, since yung salt mo ang magre-react, mamamainusan siya ng 0.02 moles. Saan madagdag yung 0.02 moles? Doon sa inyong acid component. So, the acid component will increase by 0.02 moles. So, dito sa equation ninyo, pH is equals to pKa plus log times concentration of your conjugate base divided by the concentration of your weak acid. Okay, your methanoic acid. So, tama na yun. 0.52 para sa acetate, 0.30 para sa acetic acid natin. So, since itong conjugate base mo, negatively charged, ang mag-react sa positive hydrogen ion ng acid, which is the hydrochloric acid, siya ang maminusan ng 0.02 m. Kasi nga sa kanya, siya man yung nag-react sa HCl mo. So, nabawasan siya ng 0.02 moles per liter. Saan nadagdag yung nabawas dito sa conjugate base mo? Ma-add siya doon sa acetic acid. Okay? So, madagdagan yung concentration mo ng acetic acid by 0.02 m. Nakuha? Okay? Magets nyo ba? Nakukuha ba yung sinasabi ni ma'am? Okay? Since acid, positively charged ions ang binibigay nitong acid, it will be attracted to the negatively charged conjugate base. So, maminusan, since your conjugate base will react with your acid, maminusan siya ng 0.02 at madagdag yung 0.02 doon naman sa acetic acid. Dadami yung acetic acid mo by 0.02 m. So, minus mo 0.52 minus 0.02 and then 0.30 plus 0.02, this will be the product. Okay? Divide mo siya, then add mo siya, magiging 3.74 plus 0.20. The final answer when you add the hydrochloric acid to your pH, when you add your hydrochloric acid to your buffer system, ang magiging answer niya is 3.94. So, ang original na pH ng buffer solution mo is 3.97. Nung nag-add ka ng hydrochloric acid, bumaba lang siya by a couple of points. So, from 3.97, naging 3.94 siya. Okay? So, bumaba siya ng at least 0.03. Okay? So, mas naging kaunti lang. Yung pH ng buffer solution mo, mas naging acidic by 0.03 points. Okay? Now, what will happen if you will add the base, the strong base, NaOH? So, since this is a base, okay, negatively charged na hydroxide ion ang ibibigay niya. So, saan siya where will your OH or hydroxide ions react? Doon sa positive na side. So, dito sa acetic acid. Since siya ang positive, so meaning, ang acetic acid ang mabawasan ng 0.02 millimoles. Kasi nga siya yung magre-react doon sa additional hydroxide ions of your NaOH. So, mabawasan siya. So, i-minus mo siya ng 0.02 m. Saan madagdag yung another, no? Kasi since nabawasan ang acetic acid concentration mo, saan madadagdag yun? Doon sa conjugate base na concentration. Okay? So, since nabawasan ang acetic acid concentration ng 0.02, dagdagan mo din ng 0.02 m naman yung conjugate base. So, nalipat doon yung concentration. Okay? So, tingnan nyo lang kung ano yung ina-add. If base, ang ibibigay niya is negatively charged. So, meaning yung negative charge ma-attract sa positive dito sa baba. If ang ibibigay mo naman is hydrochloric acid, magbibigay siya ng positive na hydrogen ion. Since positive yon, saan siya ma-attract dito sa dalawa? Sa negatively charged. So, kung saan siya ma-attract, doon ka mag-minus. O ha? So, ayan. So, 0.52 plus 0.02, 0.30 minus 0.02, you will get this. So, as a result, 3.74 plus 0.28 ang magiging pH level niya when you add the strong base NaOH will be 4.02. Now, i-compare mo siya doon sa nauna, sa pinaka-original pH level ng buffer solution from 3.97, since nagdagdag ka ng basic, naging 4.2 na siya. So, tumaas siya. Kasi nga, basic yung binigay mo. So, tumaas ang kanyang pH level by 0.5. 0.05. Nadagdagan siya ng 0.05. Okay? Pero, diba, kung tingnan nyo, 0.03 and 0.05 are almost nothing. Okay? Hindi ganun kalaki ang naging difference sa pH level when you added the strong base and strong acid. Because, yung solution na dinagdagan mo is a buffer solution. So, yan yung action ng buffer solution. It prevents an extreme increase and extreme decrease in the pH level. So, since buffer solution siya, ganyan lang kaliit ang na-minus at nadagdag sa pH level niya. Okay? That is how you will solve for the pH level or the pH of your buffer solutions. Okay, thank you for watching. I think that's the end. So thank you, class, and I hope you enjoyed your first chapter. We will be having our practice test later on. So I hope you will try to solve I will give you a practice test para nga ma-practice yung solving techniques ninyo. Okay? So that's all. Thank you for watching and see you on the next chapter. Goodbye, class.